So here's one I made earlier. This is a smaller version of the master geometry, which I prepared. So if we look at list totals, we can see that there are only 133 volumes in this model, but that's more than enough for an example. So what might we want to group together for imprinting and merging? Let's get rid of the top of the baked bean can, which is this tokamak, and let's see what kind of structurally we need to be stuck together. So a great start is this main vacuum vessel body, and these supports that go around the vacuum vessel body radially, and they help support these radial arms, which in turn support many other components. But let's just focus on these for now. If I wanted to select all of these, I'd right click and select similar volumes, which is a really useful feature in Cubit and will save you loads of time in large CAD assemblies that have a lot of symmetry or similar components. So now I've got all of those selected. I can select my vacuum vessel and I can draw it. And let's just have a look at this. So I would like these pieces to be imprinted and merged together so that when I mesh them, the resulting mesh is continuous. Nothing will fall into oblivion. Everything is nice and sound. So let's get one of those small bites prepared. To create one of those to get a small bite prepared, I'm going to create a group and I'm just going to call it vacuum vessel for ease. To vacuum vessel, I'm going to add this, the main vacuum vessel body, as well as these internal supports. So I select similar volumes, and then I go vacuum vessel, add vol in selection. In selection's really valuable in Cubit. It allows you to use what you've chosen in the graphical interface in the command line and makes life a lot easier. So now I've added all those volumes to this group. I can try and imprint the volumes in this group. Let's try and do this first with normal imprinting. So let's go imprint vol in vacuum vessel. You can also use the group ID if you don't want to type each time. So I could have gone imprint vol in group 34, but I'm going to name it by name for freeze. So that's imprinted, but has it done it properly? Let's start having a look. If you select something in the Cubit GUI, you can press I to remove it or to hide it. And now you can start to see the issues. None of the curves of the back surface of this support have been imprinted into this vacuum vessel. Let's try and look at some of the others. Oh, that's really strange. For this one, part of it has been imprinted, but halfway down we've lost track. So this hasn't gone quite as weird like. How would we undo that? What we can do is we can say regularize the volumes that we just imprinted. So the vol in vacuum vessel. This way, we remove that overlap. Everything's nice. Let me just move my zoom bar out of the way. Oh, sorry. I would like to know why that imprint didn't work. I'd like some kind of idea. And for that, I'm going to use one of the power tools within Cubit that can help you visualize any potential overlaps in your geometry. So to get power tools open, I just went to view and then I added power tools. And then down here on the right, and then in here, you can start playing around with volumes. So I would like to, oh no, sorry, I'm on the wrong tab. Here we go, volume IDs. I want to see if there's any overlaps going on between these components. Let's turn all the rest of it off and let's look at volume overlaps. So say, what's this component? This is 3212 and this is 618. Let's draw vol in vacuum vessel. Let's get this one again because this one, oh no, I removed the imprint, my bad. Let's have a look at some of these. Let's select two of these and see if there's any overlaps we can have a look at. And Cubit finds one volume overlap. And if we right click and we draw that volume overlap, we can see that there is a teeny tiny slivery overlap between the vacuum vessel and that support, which made standard imprinting or caused standard imprinting some troubles. So let's draw vol in vacuum vessel again. And this time, let's try tolerant imprinting. To do that, I just say imprint tolerant, vol in vacuum vessel. And if you're wondering what the tolerance value that Cubit will use to imprint is, well, you can change it manually yourself by saying tolerance and then typing in a value. But I'm just going to use the default for now, which I think is 0.05 of a millimeter. So let's try tolerant imprinting, see how that goes. This will take a second. It inherently takes a little bit longer than standard imprinting because, well, it's got to, search within some bounding regions. But if it works, it will be worth the wait. Fortunately, I've done this many times before this webinar, and I know it won't take too long, but it will take a second. 64%. The tension is building. Hey, and we're done. Okay, let's have a look at these again. Hey, that's what we want to see. That's some nice clean curves imprinted onto this curved surface on the inside of the vacuum vessel, and they all look brilliant and nice. Now that this like topology, these like surfaces have been implemented, we can merge the volumes that are in vacuum vessel together. So I'd go merge volume vacuum vessel, and we get some nice output that tells us we've consolidated 12 pairs of surfaces. There are 12 pairs or 12 sets of these supports, so that sounds about right. So that kind of just goes to show how in these really large CAD assemblies, tolerant imprinting, you kind of have to use it because unless your CAD is absolutely perfect, you're going to run into just a few troubles. Even if every alignment in your CAD assembly is great, you're going to run into a couple of odd ends. And then once you've imprinted and merged everything nicely, then you can actually start to mesh. And this is what I made earlier again, just to show off that when you do imprint and merge properly, you will be able to mesh these large geometries with little hassle. You might have to tweak some mesh sizing for individual components, but all in all, it's a lot easier having properly imprinted and merged everything.